Hence the moment you have been waiting for. You knew it was coming. You couldn't wait. You organic chemist are so excited to know that there are reactions that we can do with amino acids. Okay, so this is our first reaction with the amino acid section. And this is called the HVZ reaction. And the HVZ, again, sounds like some kind of disease that I want to stay away from. But the HVZ stands for the Hell-Volhard-Zelinsky reaction. And this is a reaction that we have talked about before in the carbonyl lectures. So if you missed out on it, go to our YouTube channel, take a look at the carbonyl folder, probably carbonyl type 3, and then you will see some videos on the HVZ reaction so that way you can review. The HVZ reaction can also be found in your text in the type 3 carbonyl chapter. So go to that actual chapter, look at that section, and refresh on the HVZ reaction. The HVZ reaction, again, Hell-Volhard-Zelinsky, is going to start with a carboxylic acid. And the carboxylic acid is C double bond OOH. And then we've got to have some kind of R group out here. So let's just do CH2 and CH3. Keep it simple. Well, we take that carboxylic acid, and we know that this carboxylic acid has an acidic alpha hydrogen. So acidic alpha hydrogen. We learned what an alpha hydrogen was in our previous organic course when we talked about the type 3 carbonyls. So go back and again review this stuff if you don't know it. So I'm going to draw our acidic hydrogen. So let's erase this hydrogen because that's the hydrogen that I've just drawn out here to the side, and that's our acidic alpha hydrogen. So if we can bring in some type of base that will pull that hydrogen off, then the first part of this reaction is going to be accomplished for us. So with the HVZ reaction back in the day, we incorporated a couple of different reagents. One of those reagents was Br2 and PBr3, and then the second one of those reagents was nothing more than water. So that set of combo reagents, what goes on is that the alpha hydrogen is pulled off and that is replaced by a bromine, and all the other parts of the molecule stay the same. So that's really all that we've done. We've taken a look at this acidic alpha hydrogen and we've pulled that off and we've replaced it with a Br2 group that's there. And this Br2 group is a very good leaving group. Good leaving group. So if I can bring in maybe another pretty nucleophile to take bromine's spot, then I can get a substitution that begins to happen. And an SN2 is the actual form of the substitution that goes on. So in the next step, what I can do is that I can bring in, because we're wanting to make amino acids here. That's what this is all about. We're wanting to make amino acids. So I can take this molecule and then I can bring in excess ammonia, NH3, and what happens is that a substitution happens and we get a NH3 group that gets substituted for the bromine at this spot, and now I have made an amino acid. So yay for me, I've made an amino acid. So amino acid, how do I know it's an amino acid? Well, look at it. I see my acidic COO group, which is going to be here, right? This is my COO. This is my alpha carbon. Off of this alpha carbon, I see my amino group. So here is my amino group. Here is my acid group. And then whatever is attached to this alpha carbon, and in this case it's a CH3, that is the R group, the random alkyl group that I need to put onto the molecule. So in this case, the amino acid that I have made is the one that has the R group of CH3, and that is alanine. Okay, so here's the take-home message of this whole HVZ reaction. Number one, you're going to add bromine and PBr3 with water, and you're going to then slam it with some ammonia, and this makes an amino acid for you. So that's what the HVZ, this particular kind of setup, will make. It will make an amino acid. It's an HVZ reaction, but because we're adding the NH3 group here on the second run, then that is basically making an amino acid for me. That is doing the substitution. So really in the first part of the reaction, what we have is an attack of the alpha hydrogen. So we get an alpha hydrogen attack, the hydrogen gets pulled off, and Br goes on in its place. In the next step, or the next part of the reaction, well, what we see is a SN2 that happens, and this is a substitution for the NH3 group. So once I put NH3 into the reaction mix, it will substitute the bromine, and now the bromine goes on, or now the NH3 goes on instead of the bromine. Number four, I want to be really careful on the starting reagent, because this is what's going to determine the actual amino acid that I will end up with after this reaction is over. So this area of the molecule is very, very important. And this is what's going to determine the type of amino acid that I'm making. So this setup, what I've drawn here, well, this is my carboxylic acid end, and this will be my amino end, and this is the R group. So if I want to make valine, I will want to make sure that that is not a CH3 group, but that's the isopropyl group that is there, and then I can do the reaction with it. If I want to make another amino acid like serine, well, I'm going to take serine, and I know that that needs to be a CH2OH group. So I'm going to make sure that the CH2OH group is at that location instead of the CH3. So that's the area of the molecule that you need to change depending on what amino acid that you want to make. So that's the reaction of the HVZ. Overall, it's a review reaction. This is not a new reaction that we're introducing. We talked about this reaction in our CTC 220 course, or Organic Chemistry 2, when again we talked about carbonyl type 3. So this is the setup. This is the reaction that you need to know. Notice we didn't cover mechanisms again. We only covered general reagents and what they do, and the steps of the actual reaction itself. If you want to know more about the reaction or the mechanism, again, go to that corresponding type 3 carbonyl chapter in your text. We've talked about it already. You had a test on it already. We did work on it already. All of that is not going to change. The only difference is that we're modifying the HVZ in this step to give us excess NH3, so that way I can substitute it for the bromine that's on the molecule. So there's the HVZ. That's the first reaction of the amino acids that we're talking about. In the next video, we're going to look at what we call reductive animation. So Walt Disney, this is not animation Walt Disney. It's animation in something else. So take a look, take a break, get you a drink, alcohol, water, wine, your pick, wine if I'm choosing, and then we'll come back and we'll take a look at reductive animation.